So we're going to do division of polynomial functions, and what I want to do is just remember how to divide real numbers. So if I want to do 1052 divided by 23, what I'm going to do is set up the log division algorithm. So 1052 divided by 23. And really I picked this number because note that that 0 being in the hundredths place, it's important that it's there. I can't just do a 1520 divided by this. That place value is extremely important. So what we do is we try to figure out how many times 23 fits into 1, and it doesn't, and 10, and it doesn't, and then in 105, we can see that it fits all the way into 105 4 times. So now what we're going to do is we're going to take this 4 times 23 and see how close to 105 we have. So 4 times 23 is going to be, I have a 12. 4 times 3 is 12, with 1 left over. 4 times 2 is 8, plus 1 is 9. So subtracting 105 from 92, we get 13. Now again, 23 is not going to fit into 13, so we drop down that last digit of 2 and see how many times 23 fits into that 132. Erasing our previous work. So we can see it's going to be 5 times. So 5 times 23 is going to be equal to 115. Now we subtract these, and of course we got to borrow, but we're going to have 17 left over. So what we can say is that 1052 divided by 23, so I can write it this way, 1052 divided by 23 is going to be equal to 45, with the remainder of 17. Now that our 17 is what we teach, grade school students, but what we know is that this is going to be 45 with 17 out of 23 left over. Or more accurately, like 45 plus 17 over 23. That's that multiplication. It's this plus this number, really. So what we have is we have something that is of the form P divided by S is equal to Q plus R divided by S. This is our division algorithm. So we're going to have let's say D for divisor. So we're going to set up this division algorithm for polynomials as well. So I will kind of set this up that way. Now what we're going to have is for our division polynomial, where we're going to have these things as polynomials, and a lot of times we're going to call this f of x divided by d of x is going to be q of x plus r of x divided by d of x. That instead of all these things being numbers, all these things are going to be polynomials. Of course, numbers still being a polynomial of degree 0. So I'm going to set that up, and we're going to use log division to divide these two polynomials. This f of x being the bigger polynomial, larger meaning larger degree, divided by the smaller polynomial meaning smaller degree. So degree 3 divided by degree 2, and we kind of can tell that our quotient is going to be a degree 1 because a 3 divided by 2 is going to be degree 1. So the way we set this up is through that division algorithm, really similar to what we did before. You put your bigger number down here, in this case your bigger polynomial, 3x cubed minus x squared minus 2x plus 6. And then your smaller polynomial over here, which is going to be that x squared plus 1. Now it's not required that you put these placeholders in there, but really this has no missing terms. I can see it, the powers drop by 1 every single time, but this one does have a missing term, that there is a 0x missing in there. And I like to write that 0. I like to write all missing terms. It helps me stay organized for when I multiply these things together. I won't have any missing pieces underneath here. So what's nice about divided polynomials is a little easier. You just kind of have to make them match. So what do you have to multiply x squared by to make it a 3x cubed? Well, this is a 1 in front of it, so I'm going to have to multiply it by a 3. And to make an x squared turn into an x cubed through multiplication, you're going to have to multiply by an x, which means that you're going to set up here above this x component, so or term. Now they have very similar place values, like real numbers. Like this is kind of like your ones place. This is kind of like your tens place. This is kind of like your hundreds place and your thousands place. But this is your x place. This is your x squared place. What you want to do is just like you lined them up before in long division, you want to line them up because they have the same place value. And now these are going to be your place values. So since I have to multiply it by a 3x, I want to put that 3x above the x place value. And then I'm going to multiply this through, and I'm going to generate a polynomial that I'm going to have to subtract, just like I did with real numbers. So 3x times x squared is 3x cubed, 3x times 0 is going to be 0x squared, 3x times 1 is going to be a 3x. Now remember that we are subtracting here, that this is a subtraction. So when we subtract these things, a lot of times I tell my students to go in there and change all the signs of these things. This is going to become a minus, that's going to become a minus, and that's going to be a minus. And even have like a red pen available to change all these signs tends to be useful. So 3x cubed minus 3x cubed is going to be 0. If you did it right, this first one's going to go away. Now a negative x squared minus a 0x squared is still going to be a negative x squared. And now this is where it would matter because that's 0, but a negative 2x minus, minus that 3x is going to give us minus 2x minus 3x is minus 5x. And just like we did before, we're going to take this and we're going to drop down the next terms. Now we just have to make a match again. So what do you have to multiply x squared by to make it a negative x squared? So you multiply it by a negative 1. Notice that it's going to go to the 1's value, or the whole number values. And then we multiply, so negative 1 times x is negative x squared. Negative 1 times 0 is going to be a negative 0x. Negative 1 times positive 1 is going to be a negative 1. Again, do not forget that we're subtracting. So I always say to my students, don't forget to, and they all say replace the signs, and that's kind of what we do, that we have to change all these signs. So, this is going to be subtracting this entire thing. So if you want to with a pen, just make that a plus now, make that a plus, and make this a plus instead, because really this negative is going to distribute through. So we have x squared minus a minus x squared, or x squared plus x squared is going to be 0, so this is going to go away. Negative 5x plus a 0x is going to be negative 5x. And then we have 6 minus a minus 1, or 6 plus 1 is going to be 7. Now we got that same division algorithm that we're going to have f of x divided by d of x. So f of x divided by d of x is going to be my remainder plus my quotient plus my remainder divided by my divisor. So we still have the same two things that we were divided by, this 3x cubed minus x squared minus 2x plus 6 divided by the divisor, which is x squared plus 1. But this is going to equal to the quotient, which is the thing that's on top again. So this is going to be equal to that 3x minus 1. And then we have plus my remainder over my original divisor. So remainder being that minus 5x plus 7 divided by the divisor, which was that x squared plus 1. So we'll run it again, and then make sure that you feel comfortable with this algorithm. So let me set up another set of polynomials. So our new set of polynomials is going to be this 5th degree divided by this 1 degree polynomial. And we're going to set it up the same way, putting the bigger polynomial, under this division algorithm. Now we have to be careful. This is missing a term. I have a 5. I'm missing 2 terms. I don't have a 4. I have a 3. I don't have a 2. I have a 1. Or I have a 0 power. So we're going to write this polynomial with its missing terms. So x squared plus 0x to the 4th minus 4x cubed plus 0x squared plus 2x minus 10. Now we're going to put the other polynomial, right here, like we did before. There's no missing terms here. It's linear, so x plus 3. And again, it's just kind of a game of make and match. So what do you have to multiply x by to make an x to the 5th? Well, x to the 4th, which means I'm going to put that x to the 4th into the x to the 4th placeholder. And now we multiply x to the 4th times x is x to the 5th. X to the 4th times 3 is going to be 3x to the 4th. Again, don't forget to subtract, which means that we're going to have to change the signs of both of these because I'm subtracting. So this is going to be a minus, and this is going to be a minus. So this will disappear. 0 minus 3x is going to be a minus 3x to the 4th. And then I drop down the next term, minus 4x cubed. Now again, make a match. What do I have to multiply this side and make it a negative 3x to the 4th? Well, it's going to be a minus 3x cubed. So this is going to give us minus 3x cubed times x is minus 3x to the fourth. Minus 3x times 3 is going to be a minus 9x cubed. And again, don't forget that we're subtracting, so we're going to subtract, we're going to have to change these signs. So I'm going to turn this to a plus and this to a plus. Notice the first one goes away again. So minus 4 plus 9 is going to be a 5x cubed. And then we just drop down the next term, so plus 0x squared. Now, again, make it match. So in order to make an x a 5x cubed, I'm going to need a 5x squared, so plus 5x squared. So this times this is a 5x cubed. 5x squared times 3 is going to be a 15x squared, so plus 15x squared. Again, don't forget that we're subtracting, so we're going to have to change these signs. So this is going to become a minus, this is going to be a minus. First one annihilates, the second one's going to be minus 15x squared. Drop down the next, plus 2x. Make a match again. So x times what is 15x squared? Well, this is a 1, so it's got to be a minus 15. And then an x. So I'm going to get a minus 15x squared. Minus 15x times 3 is going to be a minus 45x. Don't forget that we're going to have to change the signs. So this is going to become plus, this is going to be plus. First one cancels, 2 plus 45 is 47x. And drop down the next one. So this is our last go of it. So in order to get a 47x, I'm going to have to multiply by 47. So plus 47. So 47 times x is going to be 47x. And then 47 times negative 3 is going to be 141. But not forgetting that we are subtracting, so we are changing these signs. So boom, boom. So the first cancels, this is going to be minus 151. So through that division algorithm, what I can say is that, that this polynomial divided by this polynomial, I'm just going to say f of x divided by d of x because they're so long, is going to be equal to the quotient plus your remainder over your divisor. So your quotient, x to the fourth minus 3x cubed plus 5x squared minus 15x plus 47 plus your remainder, which is that negative 151. So if I have a minus 151, it'd be the same thing as subtracting that 151, all divided by your divisor, which is going to be this x plus 3.